Okay, 3.4, graphing and evaluating piecewise functions. So this can be super challenging, but once you get the idea of it, it's really pretty easy, okay? So a piecewise function is a function that's written using two or more expressions or pieces, but their domains do not overlap. It'll make sense in a little bit. So we're going to use the if statements to draw your boundaries on the graph. Graph the first function in the correct boundary. Make sure to use solid dot or open dot where the line hits the boundary. Repeat step 2 for all equations listed. Fill in the characteristics of the function. Okay, there are a few different ways, so please listen carefully. Don't fast forward through this or skip this. There are a few different ways of doing this, and it depends on what your comfort level is. Okay, and the calculator can help a lot with this. So the one way is just to remember, this is y right here. Just graph y. I don't know what's happening. Y equals x minus 1. And you just graph that. Now you should need a calculator for this one. Okay. Because, you should pretty much know that it's just a y-intercept of -1. Okay. So we go down here, we put y at -1, and it's a slope of +1, which means up 1, right 1, up 1, right 1, and so forth. And that's the line. And you can go this way too. And basically, that's your line. Okay? But the problem is we don't want the entire line of x minus 1. We only want our x values to be less than 3. So what we're going to do is we're going to take magic scissors at 3, and we're going to cut right here. Now you might want to watch this first and then determine which you like and then take the notes that way, but that's fine. Now, we want less than 3, which means we're going to now cut and erase this part right there. And since it's less than or equal, we're going to put a solid dot at 3, real big. And that's our line right there. That's our piecewise. That's the piece of x minus 1 where the x's are less than 3. All right? Then our next one. -1/3 x plus 7. So we're going to go to 7 and put our y-intercept. We can use a calculator for this also, but you shouldn't be comfortable with doing this. And go down 1, right 3. Down 1, right 3. Down 1, right 3. Can also go up 1, left 3. Up 1, left 3. Up 1, left 3. And that's my line. And you do your best job to do a straight line. If you have a straight edge, that'd be great. But we don't want the entire line. Again, we're cutting it at 3. But notice it is greater than. So first off, if it's greater than, we want right of that line. So we don't want any of this. And then also, at that line, we want a big old open dot. And that's our piecewise. Notice at 3, we have an open dot and a closed dot. So there's only one graph that includes 3. And that's piecewise. Okay? Now, another way of doing it, using the calculator more. Now, even if you use the calculator to graph those normally, I'm going to show you a way to use the calculator to do the piecewise part. So here we go, x minus 1. So y equals x minus 1. Sorry. Wouldn't have mattered, but just... That's the line we just drew. But notice, I'm going to go to my table now, and I want numbers less than 3. So I don't want 4, 5, and 6. So I'm going to move this up so the 3 ends up at the very bottom. See that? I don't have x of 4, x of 5. I want those points. And I'm going to put those points on. 3, 2, 2, 1, 3, 2, 2, 1, -3, 4, -3, -4, sorry. -3, -4, and so forth. Big old solid dot there, and then there's my line. I could put as many lines as I want. But notice how I let the calculator just use the points that work. Let's go back to the other one. Okay. So -1/3. Okay. X plus 7. There's the same line we already drew, but notice now I want values greater than 3. So I'm going to move my 3 now up to the top because I don't want any of those negative values there. So there we go, 3, 6. 6, 5. And 9, 4. And there's my piecewise graph. So whatever is best for you, whatever you feel most comfortable with, maybe practice it both ways a few times. Okay? That's how you do it. Okay, what type? Well, these are both linear. I also just realized, I apologize, I put it at 2, 6 instead of 3, 6. So notice how it's lined up on this line of 3, open dot and closed dot. Technically, though, you could also just get away with just saying it's a piecewise graph because that's what it is. It is a piecewise graph, right? But it is made up of 2 linear components, so either way is fine, okay? Now, the domain, if you look at it, really, if you think about it, it's going left forever, okay? And it's going right forever. Now, how low does it go? Well, it is continuing to go on forever this way. So it's going forever towards negative infinity. But how high does it go? Well, that's where it tops out, because up here it's also going down, starting at 6. And since it's at an open dot, we use parentheses. Okay? Now, it says evaluate f of -5. Well, where is -5? -5 is right here, okay? The red one does not continue that way, so we just got to find out where does it meet -5, and that's right down here at -6. Also, if we just plug in -5 right here, we get -5 minus 1 is -6, or we could have looked on the calculator. Okay, which is another nice reason why if you do 1 in y1 and 1 in y2, at this point, you could go back and look at either one of them. For some reason, my calculator is not turning on. Okay, I only have the second one in there, but if I put this one in here, x minus 1, right? And I know I want that one, so I go second graph, and I look at the x minus 1, which is my y2, and I look at -5, it will also give me -6. So you have your choices. And then f of 9, well, where's f of 9? F of 9 is right here. Where does that intersect? Right there at 4. But again, I could look at my calculator and go to 9, and look at y1, because that's where it is. You got to pay attention to which one's which. But if you go to 9 now, 4. Again, you could also plug in a 9 here. And that's 9 divided by 3 is 3. -3 plus 7 is 4. So your choice, a lot of different ways to do this. Whatever you're most comfortable with. And we'll talk about it in class, and you can ask questions. All right, here we go again. So absolute value of x plus 3. So I'm going to go back into my y equals, clear this out. I'm going to put in math, number, absolute value, x plus 3, which is just going to move my v to the left 3 spaces. So it's going to start at -3, 0. Okay? Now again, whichever way you want to do it, if you want to do the whole thing and cut it at -2, you know, if you want to put like even a line here and remind myself this is where it's getting cut, because you can see it's getting cut at -2. One's going to have a solid dot and one's going to have an open dot. All right? This one we're doing right now is going to be a solid dot. So you could do the whole thing and then cut it there, or just start knowing that I want this absolute value to be left of -2, less than -2. So I would just go to my graphing calculator, look at -2, and say -2, 1. That's a solid dot. And then it goes down to -3, 0. And it starts going back up again. -4, 1, -5, 2, and so forth. And it just does this like so. And that's the left part of the V, well, left of that line, a little bit of the right part, and that's it. Again, I could have done the whole thing and then said, oh, I want to cut it at -2 and just get rid of that. Whatever's best for you, whatever you understand better. Okay, the next one, 2 to the x squared minus 5. So that's going to be a parabola. I'll put in my second one. 2x squared minus 5. Graph. Now again, you can graph the whole thing and cut it and erase the left part, or I can go to my table and know I want greater than -2. So I'm going to put -2 at the top because I don't want -3, I don't want -4. And I put -2, 3. So -2, 3, and it's an open dot. And then I have -1, -3. And then I have 0, -5. And then 1, -3. And 2 is going to match. 2 is going to be +3, like so. And I could stop there. I can also do, well, 3 is 13, so that's kind of off the chart. Be somewhere up here, right? And then I just started my open dot. I come down and I go up, and there's my partial parabola. Okay, so what do I have here? I could get away with just saying piecewise. That's fine. What is it made up of? Well, it's made up of an absolute value and a quadratic. The domain, how far left is it going? Well, it's going to continue to go left, and it's going to continue to go right. That's -infinity to +infinity. The range, the lowest point is down here at -5. And it's included, so we use a bracket, and then both arrows are going up towards +infinity forever. Now, h of 5. Where's 5? 5 is on the right side. You can see 5 is off the chart. So I have two choices. I either plug a 5 in here, or I just go to my handy dandy calculator. 5 gives me 45. -7. Now -7 is over here, right? So that's on the absolute value one. That's my y1. So I'm just going to go to -7. Sorry, it takes a while to move this thing. -7, 4. I could also just plug -7 in here. -7 plus 3 is 4. Absolute value of 4 is 4. And then -2. Now, you got to be careful with this one. -2 has a solid dot here, open dot here. So we can only count the one with the solid dot. So we're going to plug a -2 in right here. 3 minus 2 is 1. Boom. Or again, look at the calculator, -2, 1. All right, number 3. What do we got going on here? All right, so we have 3 things going on here. So obviously this is piecewise. But what makes up it? What's it made up of? Well, we have a linear 2x minus 1. We have x squared, so that makes it quadratic. And then we have y equals -6. We call this a constant because there is no variable, it's just a number. Those are our 3 parts. So let's get into this first one, 2x minus 1. I already have these entered into the calculator. Now, notice how it says I want less than or equal to -2. So I'll go to my graph. This is y1. So I want less than -2. So I don't want 0, 1, 2, 3, 4. So I want to move my -2 to the bottom, like so. So I'm going to use points like -2, 5. Sorry, -2, -5. Right here. And -3, -7. And -4, -9. You notice -5 is off the chart at -11, something like that. Now, this tells me I want a solid dot. Okay, at -2, -5. I don't know why I put it there, -4. Should be -5. Good to double check our work. And I just want this part of the line left of -2. Okay, that's my border. Then I have a parabola. Now pay attention, it is a negative parabola. So when I graph it, notice it's upside down and it's lower. So I want the points between -2 and +2. Notice also they're both open dot. Okay, so I'm going to go to my table and I want to put -2 at the top and just find my numbers between -2 and +2. So we're looking at y2 for this one, -2, -8, open dot, and 2, -8. They are going to match because it is a parabola. And then we have -1, -5. And we have +1. And then 0, -4. So we have this little parabola between here and there. Just that piece. Okay. And last, we have our vertical line, y equals -6, which is pretty easy. It's a vertical line like this, but we're cutting it at 2. And we're also going to have a solid dot at 2. So that's right there. Now I want everything right of that. So I'm going to erase everything over here to the left. And that's my piecewise function. So the domain. Over here, we're going to continue going left. Over here, we're going to continue going right. So that's -infinity to +infinity. Range. This is going to continue to go down toward -infinity. That's easy. How high is it going to go? Well, it tops out right there at 4. And it hits 4, so we use a bracket. Now, where is 1? So, x is 1 is right here. Now, that only hits one of the graphs. It's the red parabola. So we're going to look at, on my calculator, or just right there, 1, -5. I could also just plug in 1 right here. 1 squared, take the opposite, -1, minus 4 is -5. Now I'm looking at 9. Where's 9? 9 is over here. That only hits the purple constant, and that's an easy one because it's always going to be that number. And where's negative 2? Negative 2 is over here. Notice it's the red one, the parabola is an open dot. It's the green one at negative 5 that has a solid dot. And that's how you evaluate it. Now, on this part, we're going backwards. Okay? So just look at this and imagine this was a whole line. Well, that's the line y equals 6. Okay? All right? Just like we had over here, y equals negative 6. But then we have to add our if. Because we're only talking about if x is, now which way is it going? It's going towards the positive side. And it's an open dot, so I say greater than. And where is it? Greater than 2. So that's the first one. Now this one, what's going on here? Well, we got to figure out this is a line. So it's got a y-intercept of negative 4. And let's see what the slope is. So actually, look, it may not be negative 4. Hold on. Let's find some nice points. It actually looks like negative 3 right there. So negative 3, what's my slope? Up 2, right 1, up 2, right 1, so that's 2x minus 3. If x, now this is going to the left, so less than, and it's a solid dot, so less than or equal, and again, where is that border wall? At 2, so we put less than or equal to 2, and that is the piecewise going opposite.